Hey guys, so for today's lesson, we're going to be talking about how to find remainders and what we're going to do with those remainders, which is called interpreting remainders. Okay, so again, we're going to talk about finding remainders in division and what we actually do with those remainders in a real life situation. So first, we're going to review over remainders, okay, which again, we've been doing that. We've been finding remainders every time we've done long division. So, we're going to do these problems. So here we have a caterpillar trying to show 34 divided into groups of 5. So what we're going to do is we're going to divide 34 as evenly as possible into 5 groups. Okay, so I just count, put 1 in each until I get to 34. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now, I am at 30 and I have 4 left and I have 5 spots. Okay, now in order to be divided evenly, that means each part of the caterpillar has to have the same amount in it. So if I were to put 1, 2, 3, 4 more, I wouldn't have any more to put in this last group, so they would not be even. So I take the 4 I have left over and put it out here to the side. 1, 2, 3, 4, and that's my remainder. Okay, so my answer is how many are in each group? 1, 2, 3, 4, 5, 6. And my remainder is what is left out of each group. It did not divide evenly. So 6, remainder 4. Okay, let's do this one. 29 divided by 6. So we're dividing 29 into 6 groups and to see how many would divide evenly into these 6 groups. So I'm going to count to 29, putting 1 in each until I can't anymore. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if I go 25, 26, 27, 28, 29, I would have one group that isn't even. So I'm going to put what's left over on the outside. So 25, 26, 27, 28, 29. So my answer is how many are in each group, which is 4. And my remainder is what is left. Remainder 5. Okay. All right. So why don't you go do this last one on your own? Pause the video and go do this last one on your own. All right, so you should have done this one on your own, so let's check it. So we're doing 47 divided into groups of, divided by 4, seeing how many groups of 4 we can get out of 47. So I'm going to count until I can't go any higher. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. I'm going to put those 3 on the outside. 45, 46, 47. So my answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 with a remainder of 3. Now again, we've been working with remainders. I'm using the standard algorithm and Super 7, so nothing's changed there. But now we're going to talk about how to interpret those remainders when involving a word problem or a problem-solving question. Okay, so let's look at this question. The 4th grade class at LSK is taking a field trip to the museum. There are 96 students going on this field trip. They will be taking small buses that can fit 7 students per bus. So we have 2 questions. We have how many buses will they need and how many buses will be full. So we have 96 students total, and we're going to be dividing those students by what number? By 7. So we're going to take 7 students, put them on a bus. 7 other students, put them on a bus. So we're dividing them into groups of 7. So let's go ahead and do that using either the standard algorithm or Super 7 method. So I'm going to use the standard algorithm. Okay, so we're going to divide 96 divided by 7. Now remember, we can write our multiples of 7 to the side. So 7, 14, 21, 28, 35, 42, 49, 56, and 63. Okay, now we're going to see how many times can 7 go into 9. While I look over at my multiples, I can go 1 time. Okay, 7 times 1 is 7. We subtract that. 9 minus 7 is 2. Okay, bring down the 6. Bring down the door. Divide once more. 7 goes into 26, not 28. Can go to 21, which is 1, 2, 3 times. Okay, 7 times 3 is 21. 26 minus 21 is 5. Okay, so remainder of 5. So let's talk about our answer. Okay, so we just divided 96 into 7 and got 13 with 5 left over. Now the 13 represents our number of buses. The leftovers represents how many students were left over. Okay, because again, we're dividing 96 by 7, putting that on a bus, 7 kids on a bus. So we got 13 buses, and then we have 5 kids left over. Now this is where we're going to interpret the remainder. What do we do with those 5 kids? Are we going to leave them back at home or back at the school for the field trip? No, we're not going to leave them. What are we going to do? We're going to get another bus, okay? But the difference is this bus would not be full. So we have 13 buses, and then these 5 kids are going to get another bus. So really we have 14 buses. So that is when you take the remainder and add 1 to your quotient. When you need 1 more of something, it just won't be full. Okay, so that's when you use the remainder as a +1 to the quotient. Okay, because we're not going to leave those students behind. We're really taking 14 buses. Now the next question says, how many buses will be full? Now in this case, we're not going to use the remainder because they just want to know how many buses would actually be full. So for this question, we would what they call drop the remainder and go with our whole number here. So how many buses would be full? Well, we would have 13 full buses. Okay, that's not how many buses we'll need. That's how many would actually be full. Okay, so now we're going to do a few more and determine what we're going to do with that remainder. Okay, so here, let's look at this question. There are 32 students in a 4th grade class. Each table holds 6 students. How many will they need? So we're going to divide 32. Oh, not 36. 32 divided by 6. Okay, now that's when we can just go look at our chart and find that 6 can go into 32 5 times with 2 left over. Okay, so now let's look at our question. How many tables will they need? Okay, so 6 students at 1 table, so we can get 5 full tables with 2 students left over. Are those 2 students going to sit on the floor? No, they're going to sit at their table. So this is where we're going to add 1 to the answer. So how many tables would we really need? We will need 6 tables. Now we're not doing 5 plus 2 because remember the 2 represents the students left over and the 5 represents full tables. Okay, so we just take those 2 students and add 1 more table. It just wouldn't be full. All right, next question. Pokemon cards are on sale for $7 a packet. Patricia has $30 to spend on Pokemon cards. How many cards can she purchase? Or how many packs of cards can she purchase? So she has $30. She's going to see how many she can get that are $7 each. So we're going to do 30 divided by 7. Again, we can look at this on our chart. We can see that 7 can go into 30 4 times. 30 minus 28. So we'll have 2 left over. All right, remainder of 2. So let's think about this question. How many can she purchase? So $30. So each time she bought a pack, she spent $7. So she did that 4 times, okay? And she has $2 left over. Is she going to have enough money to buy a 5th pack? No, she's not. So in this case, this is a case where we're going to drop the remainder and only answer how many packs she was able to buy. Okay, it never said she had to spend all her money. Okay, she was only able to buy 4 packs with the $30 she had. So that $2 that are left over, she can just take back home. So again, this is a case where we're going to drop the remainder and only answer with the whole number. Okay, let's read the next question. There are 56 students on a swim team. How many relay teams of 6 can the team make? Okay, so we have 56 students and we're dividing them by 6 because we're going to take 6 and put them on a team. Okay, so 6 goes into 56 9 times. Okay, 54. So 56 minus 54 is 2. So that's our remainder. So let's think about this. So this is how many total kids we had. We're dividing them into teams of 6. We are able to get 9 teams with 2 students not on a team. But let's look at our question. How many relay teams of 6 can the team make? So that's similar to asking how many full teams do we have. We're not saying we're leaving these students off of a team, but they want to know how many teams of 6 can we make. Well, we made 9 teams of 6, okay, and there'll be a team of 2 or whatever. So there'll be 9 teams of 6. Those are how many full teams we had. All right, 9. All right, let's do the next one. "39 students chose to go canoeing on a school camping trip. Only 4 students are allowed in a canoe at a time. How many total canoes will be needed for all the students to participate?" Okay, so we have 39 students going. They're going to divide them by 4 because only 4 kids can go in a canoe at a time. Oh, no, I wrote 36. Whoops. 39 divided by 4. Okay, so we're going to see how many canoes we need to fit 4 students. All right, so 4 goes into 39. It's a basic fact, 9 times. Okay, 39 minus 36 is 3. A remainder of 3. Okay, so we have 9 full canoes, but they want to know how many total canoes for all the students to participate. So we have 9 full canoes and these 3 kids left over. So what are these 3 kids going to do? Well, they're going to get their own canoe. So we really need how many canoes? 10, not 12. Remember, because the remainder is how many kids are left over. And the 9 is how many total full canoes we have. But we're not going to leave these kids out. We're going to give them their own canoe. So this is an instance where you add +1 to the whole number. So we need 10 canoes, not 9, to make sure all the students get to participate. All right, now pause the video. You go do this last question on your own. Go do this last question on your own. Okay, so you should have done this last question. 62 4th grade students are going on a field trip to the park. They will travel by car. Each car holds 4 students. How many cars will be needed? This is almost exactly like the bus question we just did, except now we're talking about cars. Same concept. So we're taking 62 4th graders, dividing them by 4 for the cars, okay? So we're going to do standard algorithm. Now, this is not a basic fact, so you had to follow the steps of standard algorithm. 4 goes into 6 1 time. 6 minus 4 is 2. Bring down the 2. Bring down the door. Divide once more. 4 goes into 22 5 times, which is 4 times 5 is 20. 22 minus 20 is 2. So we have a remainder of 2. So we have 15 cars that are full and 2 kids that haven't gotten a car yet. Are we going to leave them behind? No, we're not. So this is when we're going to add 1 more. So we're not having 15 cars. We actually need 16 cars. Okay. So those are how we can interpret the remainder. You're either going to drop it or add one. Now, sometimes you may have a question that says, how many are remaining? That's when we're just going to answer. Like if I were to ask, how many students were left out of the full cars, we would answer 2. Or on this much, if we asked how much she had left over, it would have been $2. Okay, so sometimes you may be asked how much is actually left over. Okay, so let's talk about your work for today. You have an assignment that's called Interpreting Remainders. Okay, it's a Google Slides assignment. All right, each green box is a text box to type in. All right, so this first slide, you're going to drag and drop the flowers, kind of like we did on the caterpillar. So 19 divided by 4. So you're going to put equal amounts of flowers in each vase, and whatever's left out, you're going to put in this box. Then you're going to type the division problem. Then you're going to answer these questions. How many tulips go into each vase? So that's just counting how many are in each vase. Then how many tulips are remaining? That's how many tulips are here. Remember, each vase has to have the equal amount. If you can't put an equal amount, that is what is remaining. Okay, same thing here with these tables and chairs. Okay, you're going to drag and drop. Now, if for some reason you're having trouble dragging and dropping, you can do it on scratch paper and then type your information here. That's okay, because I know sometimes it can be tricky to drag and drop. So if you're having trouble, don't stress about that. Do work on the paper and then type your information here. Okay, this slide's the same thing, except it's books on a bookshelf. Okay, you're going to put books on each of these bookshelves. And this is the same thing, says cookies in a bag. All right, then we get down here, we're taking the model away. Okay, so this says there are 58 people signed up for a tour of the lighthouse. Joe, the tour guide, can take no more than 7 at a time. So you're going to do the division problem on Scratch and fill in the information here. Then you're going to answer the questions. Okay, so if I were to fill this in, I would write 58 divided by 7. Okay, 58 divided by 7. If I look at my chart, I can go, I think 8 times, which is 56, with a remainder of 2. Okay, so then we're going to answer these questions using our whole number and our remainder. How many tours of exactly 7 people can Joe take? That means full tours. Okay, so this is your full number. So he can take 8, which that's using our quotient only. So we're going to put the Q there. Using our Q stands for quotient. Okay, again, there's a key down here at the bottom for what each card represents. Now, what is the total number of tours that Joe must give today? Well, he gave 8 full tours, but he had 2 people left out. So this is where we add 1. Okay, so he actually gave 9 tours. All right. Then the last question says, if Joe gives tours to all of the groups of 7 first, how many people will be in his last tour? So that's how many people are left over. Okay, there are 2 people left over, so that is our remainder. So make sure you're typing in all the boxes, okay, and matching the card with what part of the answer you used. Did you just use the quotient? Did you do the quotient plus 1? Or did you just use the remainder? Okay, that's how these next few are going to be. They're going to be the exact same of what we just did. And again, there's directions here at the bottom if you forget what exactly to do on these slides. And then the last one is just word problems like we just did in the lesson. Okay, just make sure you're reading what exactly the question is asking. Like your answer should not be 8 remainder 2, 2 remainder 3, or whatever. You need to only put the part of the answer it's asking. Is it asking for just the quotient? Is it asking for the quotient plus 1? Or is it asking for just the remainder? Make sure that's what you're doing, because if you just do the division, 84 divided by 9, and tell me 9 remainder 3, that's not answering the question. You just did the division. You didn't write the answer that is actually correct. Okay, if that makes sense. So like up here, like how many tours of exactly 7 people did Joe take? I didn't write 8 remainder 2. That's not how many tours he took. How many full tours or whatever he took. He did 8 tours. Okay. So again, make sure you're writing exactly what it's asking, not just the division with the remainder. Okay. And I'm going to remind you that y'all need to be working on your morning work for this week. Okay. This is due on Friday. You skip Tuesdays. So we're doing Wednesday, Thursday, and Friday. Okay. And I'm going to give you your secret word for today. Remember, we're doing a secret word every video I make. So I've already given you 2 this week. Your third secret word is a repeat of one of the other ones. It's happy. Okay. So your third secret word is happy. All right, make sure you write that somewhere. And on Friday, I'll post a Google form. It's already ready to go on Friday for to enter the secret words for each math video for this week. All right, let me or Mrs. Reisler know if you have any questions. We hope y'all have a great day and let us know if you need any help. See y'all later. Bye.